This is Professor Kat Barger with the Physics and Astronomy Department. So today what I'd like to talk to you about is a big picture idea where we look at what's happening with our own galaxy, the Milky Way, the galaxy of which we live in. So if we were to look at this galaxy, it turns out that it doesn't grow and evolve by itself. If we were to look around our galaxy, it is surrounded by numerous massive gaseous clouds. And when I talk massive, I mean they're on the order of millions to billions of times the mass of our own sun. These gas clouds are flowing into our galaxy. They're flowing out of them. They're going in different directions. Some material is being drawn in for the first time. Some of this material is being ejected out of our disk. Our galaxy lives in an ecosystem. This ecosystem is important for the health of our galaxy. And what do I mean by health of our galaxy? Well, if we were to look inside our own galaxy and we were to think about how many stars it has and how much gas it has and how quickly it's making stars out of that gas, it turns out that what we would find is that our galaxy is quickly making new stars out of the gas at such a rapid rate where we have a fuel crisis, we have a gas crisis, where after a very short amount of time in galactic lifetimes, 2 billion years, our galaxy is going to run out of gas completely. It won't be able to make new stars. And if it can't make stars, then our galaxy will become colder as stars eventually die, including our own sun, which will itself die, as far as we're concerned, in another 5 billion years. So, do we think that that's the end of our galaxy? Well, luckily it's not, because as I mentioned earlier, there's a whole bunch of gas clouds, some coming to, some coming from. So let's talk about the ones that are exiting out of our galaxy real quick. Now, it turns out that as the material gets kicked out of our galaxy, it rockets up to very high heights, but as it tries to get up and escape out of our galaxy, it turns out that our galaxy has a very strong gravitational pull, a very strong gravitational attraction. That material just can't escape. So instead it does a fountain process. It loops back around. Just like if you were to throw a ball up in the air, no matter how hard you throw, the gravitational pull of the Earth is just going to pull it right back down. Now, in addition, we mentioned that there was other gas clouds that are also flowing to our galaxy for the first time. Some of that gas is associated with nearby other galaxies. Now, most of the time when we think about nearby galaxies, we think Andromeda because it's a very big, nearby, beautiful galaxy. But the thing about Andromeda is that it's our nearest large neighboring galaxy. That galaxy is about 2.5 times more massive than our own Milky Way, so it's quite big, and it's quite far away. As far as swapping materials going back and forth goes, that galaxy is destined to interact with us in about 4 billion years, so it's too far away in order to bring material to us. Now, we also have a whole bunch of other galaxies, small galaxies around us. Just like how Jupiter has a whole bunch of satellites orbiting around it, we have a big planet with a whole bunch of moons going around it. Our own Milky Way, a large galaxy, has a whole bunch of small galaxies known as dwarf galaxies surrounding it. Now these dwarf galaxies, sometimes they get a bit too close to our Milky Way and gravitational tidal interactions can siphon material off of these galaxies. And every once in a while, these galaxies just get captured completely and gobbled up. Our own Milky Way galaxy is a cannibal. It feeds off little galaxies and it helps to grow it up bigger and bigger and bigger. And our own galaxy started out years ago at the early stages of the universe, very, very small. It was a tiny, small galaxy just like all the other galaxies at that time. But our own galaxy is very big today. And how it got big was in a large part due to cannibalization of other galaxies. In addition, our galaxy also grows because after the Big Bang happened, although there were stars forming and there were galaxies forming, some material just never found a home. It just stayed between galaxies, leftover material. Well, that leftover material slowly coalesces onto these big galaxies and feeds them up too, which gives them enough material to continue to form stars for very, very long periods of time. So with all these sources, gas sources, with all these gas clouds surrounding our own galaxy, through galaxy cannibalization and by eating up the leftovers of the formation of the universe, the lingering gas between galaxies, our own galaxy is able to build itself up and grow. Now it turns out that figuring out where these gas clouds have came from is a big, big task for astronomers. Every single gas cloud is unique and has its own signatures and properties. And these signatures they're not always as telling as you would like them to be for where they came from. Turns out that gas coming from the far reaches of space between other galaxies, the leftovers from the formation of the universe, can look very similar to gas that has been stripped off of small dwarf galaxies. And so we know that our galaxy has been forming stars for a long time, and we know we have lots of gas clouds surrounding our galaxy, but we don't really have a clear understanding of how that cycle all fits together. We know that our galaxy has an ecosystem that keeps it healthy, and that our own galaxy is likely going to be able to form stars for much longer. But just like the United States, there is a gas crisis, and our own galaxy needs renewable energy sources in order to keep itself going. Thank you.